Hi guys, welcome to the lesson on medians and altitudes for triangles, or of triangles. We began the class with a simple do now. We had triangles and we were looking for the balancing point on our triangle. Once we found it, we just kind of wrote it on the actual triangle. This lesson again is called medians and altitudes of triangles. So our objective for today is giving an understanding of perpendicular bisectors. Students will analyze properties of medians and altitudes of triangles. So we continued our exploration of this triangle by measuring each side or each segment of the triangle and finding its midpoints. So we found the midpoint of each one. After we found the midpoint, we constructed segments from the midpoint to each vertex or vertex. So the midpoint to vertex, midpoint to vertex. We noticed that they all intersected at one point and we labeled that one point. So then I asked you guys to kind of analyze what you saw between our center point that we found by measuring and the center point or the balancing point you guys found on your own. Well, we noticed then when we create a segment from a midpoint to a vertex, this actually has a definition. It's called a median. So here's a definition. It's a segment from the vertex to the midpoint of an opposite side of a triangle. And that balancing point that we found in our opening activity is actually called the centroid. So three medians of a triangle are concurrent, or when they are concurrent, that means they all meet at one point, then this point is called a centroid. So again, you can kind of think about it as the balancing point is also the center point or the centroid. Centroid would be our vocab. So let's look at our first example. Here we have in triangle RST, Q is the centroid. So we know that Q is our centroid, so here is our Q. And SU is equal to 8. So it asks us to find what RU is and SR is. So RU would be this side of our triangle. So again, if we know this is the centroid, then we know that each of these segments was constructed by midpoints. So this U has to be the midpoint of SR, meaning if SU is 8, then RU, or segment RU, is also 8. And then it asks us to find what SR is. So SR would be the entire segment. So if I have if I have two pieces that are both 8 and I want the entire thing, then this would be the equivalent of 16. And that's it. So we had a few more examples for example 2, or a few more versions of this example. For the red, we needed to find what RU is. Again, this is the mid segment, or I'm sorry, this is the midpoint, meaning this segment should be equivalent to RU. So for red, this would be equal to 6. For ST, same deal here, or I'm sorry, same deal here. This is the midpoint, meaning that this would also be 7. So if I wanted to get the full measurement of ST, it would be equivalent to 14. And the last one is our green one. So we want the perimeter of the whole entire triangle. So if this is 6, SU is 6, RU would also be 6. Since TW is 8, RW would also be 8. So then we just add 12 plus 14 plus 16. Let me do that real quick. And that would give us 42. So our perimeter is 42. So here's a little bit more vocab. We also introduced altitude. Altitude is the perpendicular segment from a vertex to the opposite side of a triangle. So altitude would be a way of thinking maybe the height of a triangle. So we want to know what the height is for this example. Where all of our altitudes meet, this point is called the orthocenter. So the point at which the lines containing the three altitudes of a triangle intersect is also called our orthocenter. So for example 3, I have draw an acute angle and then find its orthocenter. So I'm going to go ahead and just draw any kind of acute angle. Remember, acute is less than 90 degrees. So here is one triangle. And I want to find its orthocenter. So if it's from perpendicular or if it's from vertex to the opposite side and it has to be perpendicular, that means that my segment from this point here to here should be perpendicular. So it doesn't necessarily have to be the midway or the midpoint. It just has to be perpendicular. And again, perpendicular creates a 90-degree angle to our opposite side. So that's perpendicular. So if I were to go down, this would probably be there. And then my last one would be a little bit. Let's try that again. If those were straight, they would all meet at that one point. That would be called my orthocenter. Sorry about that. So here are a few more examples of orthocenters. So when we had an acute triangle, we realized it kind of stays inside a triangle. It doesn't necessarily always happen that way, but for this instance, it kind of does. For our right triangle, here's our example. They kind of all meet at the point P. And if it's an obtuse triangle, it's outside of the triangle. So you have three cases. It's inside, on the side, and outside. Very similar to our centroid. And that's the entire lesson, guys. We had an exit slip and we closed it up. So this one was a short one. I hope this video helped. And again, have a good day.